Hello class, today we're on lesson 5 of chapter 5, more on solving equations. Very important chapter that you're going through right now, and as it forms the base of your knowledge so that you can further apply this in math and in sciences as you would learn how to solve equations. And we have an illustration here of a teacher writing 1 apple plus 1 apple is equal to 2 apples, and the student turns around to the other student and says, being a scientist is going to be a lot easier than I thought. Well, it's not that easy, but at the same time, it's a lot easier if you truly understand how to handle equations. So let's continue here on page 206. All of the equations in lesson 3 had something in common. The variable appeared only on the left side. And here's an example of an equation in which the variable appears on both sides. So now, instead of just having the variable on one side, let's go ahead and grab my pen. And we're going to write 5x plus 1 is equal to 2x plus 7. Now, as we read on, we have a picture illustrating this equation shown here. So if we were to write our boxes and our circles, we would have 5 boxes on this side. Okay, so there's 1, 2, 3, 4, and 5, and then we would have one circle. All right, and this is our little scale. And on the other side, as this would be a balanced scale, we would have here 2 boxes. Okay, and then we would have 7 circles. So let's just make 7 circles. So these are equal. Okay, if this were a scale, this would be right in the middle, let's just say, if this were some sort of a contraption. And of course, it's just my makeshift scale. Obviously, if it leans this way, that means this is heavier. If it leans that way, it's heavier to the other side. But we know right now that it's perfectly in the middle. So let's figure out here what could we do with what we've already learned so that we can solve this problem. It says here, the 5 boxes in one circle on the left pan of the balance represent the expression 5x plus 1. So we see that. And the 2 boxes and 7 circles on the right pan represent the expression 2x plus 7. To solve the equation for x, is equivalent to finding out how many circles will balance one box. Okay, so you're basically looking to see at the end, we want to know what one box is equal to, right? We want to see one box here, and we just don't know how many circles. That's what we're trying to find. And remember, the box actually represents x. We have 5x, 5 boxes, and 2x for 2 boxes. So somewhere at the end here, we want to know what x is equal to. So one way to do this is shown below. The corresponding steps in solving the equation are shown at the right. So we're going to follow each of these. We have our 5x plus 1 is equal to 2x plus 7. We already have that. Now we remove 2 boxes from each pan. So we're going to have to take out 2 boxes from each pan. And what would that look like? Well, if we took 2 boxes out of one pan and took it out of the other pan, in this side we would end up with, I'm sorry, I shouldn't be writing that. It's going to be on the left. I would end up with 3 boxes on this side, right? I would still have one circle, but I would have no boxes over here, right? And I would have my 7 circles still, okay? Now, if we had done that over here, I'm going to write it underneath. Had we subtracted 2x from each side, that would have given us the same. 3x plus 1 is equal to 7, because we're removing the 2x here, so we would be left with no x's, and we would only have 3x here. So 3x plus 1 is equal to 7. Now, we're going to remove a circle from each pan. You might say, well, why? Well, remember, we're trying to achieve one box here and as many circles as are left over here. We're trying to find out what one box weighs in terms of circles. So in other words, we're going to remove this one because I don't want circles. Over here we removed the boxes because we didn't want boxes over here. In fact, we want all the boxes on one side, and we'll see why in our next step. But over here we're definitely going to have to remove the circles because we're not supposed to have any circles on this side. So we're going to remove one circle from each side. And what are we left with? Well, we're left with 3 boxes over here, and we should be left with 6 circles, okay? Because we removed one circle from each. So if I were to subtract 1 from each side of the equation, I would end up with 3x is equal to 6. Okay, and I'm just keeping these lined up so you can see what's going on underneath. We could have simply crunched these together and just put 3x is equal to 6, but I want you to see them being actually subtracted from each side. So now at this point, because 3 boxes are balanced by 6 circles, one box would be balanced by 2 circles. Well, how do we know that? Well, we know that for every box here, there's 2 circles. If we were to divide these boxes into 3 equal parts, right? Let's see. Divide them into 3 equal parts. I'm going to change that same illustration there just to show you. I have one box, and I have 2 circles, and I have another box, and I have 2 circles. So we're just separating these. We're dividing them separately into their like their corresponding value for each. So we have one for every box here. I have 2 circles. I have 6 circles. In fact, we would divide, and what we would ultimately get here is, and let me go ahead and just clear this up so I can write down one circle. Clear that. And so we're now left with one box, dividing this by 3, and that means I would have, I have 3 sections, right? 3 sections here. I would end up with 2 circles. And the same thing we would have done here. We would have divided this by 3 and this by 3, and we would have gotten x, because 3 over 3 is equal to 1. X is equal to 6 divided by 3, which is 2. So you can see how we've used the illustration to show you how you actually perform these functions with an equation. The procedure in solving the equation is to transform it into equivalent equations that become progressively simpler. In the last one, the variable appears by itself on one side of the equal sign. There is always the goal of solving an equation. To make sure that the equations that we write are equivalent to the original one and to each other, we can do the following. Now, we already learned this in lesson number 3. Add the same number to both sides. We can do that. We can subtract the same number from both sides. We can multiply both sides by the same number other than 0, and we can divide both sides by the same number other than 0. And lastly, we can change the form of either expression by using the facts that we know about equivalent expressions. Okay, so we've already learned that, and we're going to go on here to our 2 examples. So here's some examples on the steps, on how these steps can be used to solve equations. We're going to flip over to page 208. We have example number 1, and let's go in here and should be able to get a new board. Let me get my pencil back, and we can move on. We have here, solve the expression 3x plus 10 is equal to 7x minus 2. So 3x plus 10 is equal to 7x minus 2. Now, because the variable appears on both sides of this equation, we might begin by removing it from one side. One way to do this is to subtract 3x from each side. So we could do that. And notice that we like to have the x on this side, but if I subtract 7x, I'm going to end up with a negative over here because I would have a smaller 3x and a larger negative 7x, or I'm subtracting a larger. So in order to avoid that, we could always pick whichever is the smaller one to eliminate. So in this case, we've chosen to eliminate 3x, okay? And I'm putting that negative 3x is equal to negative 3x. We're adding that. We're subtracting 3x from both sides. These are, in a sense, it's an equivalent operation. We're doing it on both sides. So what we end up here is 10 is equal to 4x minus 2 because we subtracted 3x from 7x and we ended up with 4x. Okay. Now, what we want to do is to add. Now that might sound strange, but see, we want to remove this negative 2. We want to remove the subtraction. We have to go with the inverse operation, which means in this case we're actually going to add 2. We're going to add 2 because we'll take that negative 2 and turn it into 0 by adding 2. So what do we get? Well, we'll end up with, and you can draw lines underneath if that helps you. It's sort of like the old math way of adding. But we'll end up with 4x on this side. The negative 2 and the positive 2 eliminate, excuse me, and then we'll end up with 12 over here. So 12 now is equal to 4x. Now if we divide both sides by 4, we would end up with 3 is equal to x. And we know that we can always turn that around and say, well, x is equal to 3. So let me write that over here because we want to use this also to check our solution. So we can say 3 is equal to x, just as the same way we can say x is equal to 3. So let's go back and check our solution here by putting 3 into the value of x, and what will we have? Well, we have 3 times 3 is equal to 10. Oh, I'm sorry, it's not equal to 10. 3 times 3 plus 10 is equal to 7 times 3 minus 2. As you can see, we substituted the value of 3 for x because we found that to be the answer. And what do we have? Well, we have 9 plus 10 is equal to 21 minus 2. And 9 plus 10 is 19, and 21 minus 2 is 19. So we see that it's true that for x, when x is equal to 3, the answer, or rather, when x is equal to 3, this is a true statement. Let's go ahead into example number 2. And in example number 2, we find solve the equation 4 times x minus 11 is equal to 6 minus x. That's a terrible 6. Let's rewrite it. Okay, now we're getting challenged here because we're given something a little more than we had before. In fact, we're going to have to execute the distributive rule because we need to determine what these two terms are. We have two factors, so we'll now multiply 4 times x and get 4x, and 4 times negative 11 is negative 44. I like to look at it that way. We'll discuss that further along in our in our year as we view these values. But anyway, we now have this equation. So the first thing you might want to say, well, how can I isolate the x variable on one side? Now here I have a negative x. If I were to subtract 4 here, I would end up with a negative 5x. So that may not be the course of action that I'm interested in. What I'd probably do is instead add x to this side as well as to this side. And why would I do that? Well, it remains positive. It's not to say that you couldn't do it, but it's one less negative that you need to carry around and one less opportunity for you to make a mistake. So I'm adding x here, and I would end up with 6. Negative x and positive x is equal to 0. And here I have 4x plus x is 5x. minus 44. Now we're in very familiar territory. We know that all we have to do here is add 44 to each side. We have a negative 44. So let's go ahead and add 44. I'm putting these little negatives, excuse me, these equal signs. Okay, so we've added the 44 to each side. That will give us 5x is equal to 6 plus 44, which is 60, or excuse me, 50. And when we divide now each side by 5, we would end up with x is equal to 10. And again, we can go ahead and plug that in. As we can see in our book, we substituted 10 for x, and we would have, just looking at the book, we have 4x, 4 times parentheses x minus 11 end parentheses is equal to 6 minus x, and we would end up with 4 times 10 minus 11, which is negative 1, and 6 minus 10, which would be negative 4. And 4 times negative 1 is equal to negative 4. So we know that 10 is correct. We'll move on to some of these exercises in our next video.